Hey, this is Flippin' Algebra, Carnegie style, with Mr. Frazier. How's everybody doing? Uh, Hopefully you're not too disgusted by seeing me at your house. I am upside down. I will turn it over here so you can see me a little bit better. Hello. Alright, so we're going to be doing Lesson 2-3. And hopefully your child is watching this today in class and or is watching it at home late at night. I'm still here at school trying to finish it up. I will show you really quick that behind me is the assignment board that tells them what to turn in when they come into class, what they turn in before they leave, as well as what their homework is. And then over on the other side of the room is their vocab board. You can see it's not quite as extensive as my geometry, and I'll show you that in a minute. That's what they have to look forward to. And then over here you have what they're going to learn every day. I post that in the morning. They should know, hopefully, when they're there, what they're supposed to be working on. And then over here, I like to show people this simply because this is what's coming. This is geometry. And as you can see, their board for vocab is a lot more intensive. So just so you get what we're going to see in the future, I'll go ahead and spin this enough. Okay, and we'll continue today. And 2-3 is relatively short, so I'll try and make it short and sweet. We talk about a few things that they've done in the past, and introduce them to some things that they're going to see in 2-4. That would be tomorrow's lesson. Alright, so 2-3. 2-3 deals with inequalities. Okay, and inequalities are correct. They're your less than, greater than, less than or equal to, greater than or equal to signs. And these are the ones we're mainly dealing with in 2-3, as well as in algebra. I will say that there are other inequality signs like approximately or approximately. This is actually similar to, this is approximately, this is not equal to. So these are all signs of inequalities. Okay, and then we've dealt with expressions. Okay, and that's something like this, 3x plus 4. That's an expression. And then you have equalities, or an equation. An equation is nothing more than an expression with an equal signs. So this would be an example of an equation. If it said equals 10, that would also be an equation. Okay, and then we have function notation. These are things that are reviewed. And this one should be one that they're sick of seeing. Function notation, and that's when we use f of x. Or whatever the variable may be. And in this case, it's x. Okay, function notation. So, what are some other things we're looking for? We're looking for tricky words, because a lot of the stuff that they're going to be doing are word problems. And some words have a tendency of seeming like they have one meaning, but in actuality they mean the opposite. Okay, so tricky words I like to tell them to do flashcards for, just like their vocab. So I'm hoping that you're going through flashcards with them, or they're making flashcards, especially if they're struggling. Okay, and words like this, at least. Okay, the words at least actually mean greater than or equal to. Okay, the words at most mean less than or equal to. Okay. Maximum. Again, means, and I'm forgetting my S's, less than or equal to. Minimum means greater than or equal to. So these are all words that you're going to see that have reverse meanings than what they think. You know, when you think maximum, you're thinking big. And in actuality, they want everything less than or equal to. Okay, so getting used to seeing these words and understanding their meanings will help them tremendously when writing a problem. Especially after we've already talked about how to write an equation. And now we're going to start talking about writing an inequality. All right? So what is an inequality? An inequality is something that has multiple right answers. Okay, and the type of inequalities that they're used to seeing would be for, say we go to Busch Gardens. You must be at least 48 inches to ride this ride, which means you have to be greater than or equal to 48 inches. Okay, so they're used to seeing these inequalities all over the place. Now they'll tell you they have no idea, but you have. You've seen these inequalities. You've seen them for when you go to the grocery store, or you go to shop at the mall. You get on an elevator, you know, this elevator holds only 1,000 pounds. Well, that means everyone in there must weigh less than or equal to 1,000 pounds, or it's not going to work. Okay, so these are all things that you have seen before. What we go over is how to graph them. And we start with things called simple inequalities. Now, simple inequality is just one inequality. Okay? So this x is less than 5 is one inequality. It's a simple inequality. It's one inequality. All right. Now, how would I graph that? Well, we put that on a number line. Our dot is always our number. And in this case, our dot is 5. Now, you see I put a closed dot and an open dot. Well, what's the difference? Well, you can only use a closed dot when you hear the words equal to. Otherwise, you have to use an open dot. So equal to, closed dot. Don't hear equal to, open dot. All right. So next comes, what direction do I draw the line? Well, we start with the variable. I need all the numbers less than 5. Well, on a number line, everything less is to the left, and everything more is to the right. So let's look at another one. This one looks a little different. Why? Because the x is on the other side. Well, I always read from the x so that I know which direction my arrow is going. So when I read this, x is greater than. X is greater than or equal to negative 2. X is greater than or equal to negative 2. Okay, so I know negative 2 is my number, and I put an open dot. But wait a minute, I think I used the word equal to. So now I got to close it. It is a solid dot. And x is greater than or equal to. So that means I've got to go to the right. Okay? So not a complex process, but one that they have to get used to doing. Okay? So that's the first step. The next step would be solving an inequality. Now, this is done exactly like an equation. There's no difference. So I'm going to give you an example of one. Let's say I do 3.75x plus 25 is greater than or equal to 1,500. Now, this one's not just a random problem. You should notice it came right from your book. And when I look at this, I go, okay, let's pretend that was an equal sign, and I'm going to solve this equation. So the first thing I do would be minus 25 to get rid of that. And I'm left with 375x is greater than or equal to 1475. And then I would divide, because I got to get rid of this. This is a multiplication problem. I divide everything by 3.75, which leaves me with x is greater than or equal to 393.3 repeating. Alright, so that means any number bigger than 393.3 is going to be a correct answer. Okay? Now, what happens when the answer has words? Well, if we were talking about money, we wouldn't say 393.3 repeating. We would say $393.33. Well, why would we say 33 cents? Because we don't have any units that are smaller than that when we're dealing with money. So this is the part of the problem where a lot of kids have a rough time, because they'll do the math correctly, and then when they're asked for the answer, they don't write the answer in the units that they're talking about. Like, they forget about units. Well, we'll just forget about it. So it's important that you make sure you remember your units and what is a possible answer. Okay? So if it said there were 35 boxes, hopefully you know you couldn't have 35.5 boxes, right? If you could have at most 35.5 boxes, that means the maximum amount of boxes you can have is 35. Why? Because they don't really sell anything in half a box. People get a little upset with that. Okay, most of your boxes have to be full. Imagine if they sold you Girl Scout cookies with half a box. We've talked about this. You'd probably be a little bit upset, especially if they charged you for a full box. Okay, so understanding what you're reading and the situation you're in is important to understanding what your possible answers could be. And that makes the difference between our discrete and continuous. And again, the same type of graph that we were talking about before. All right. So being able to answer a problem and then graph this. I could graph this. I put it on a number line. What would I use? I'd use a closed dot. I'd use 393. And then I would say everything greater than it. There you go. And it would be 0.33. $393.33. And I need anything greater than that. Alright? So you could graph it. Now, what is more likely to be seen? Well, this is a graphed answer. This is a linear equation. Okay? And we have practiced graphing linear equations. So let's just look at this one, and I'm going to do a generic linear equation. We know that we're supposed to start at what number? 25. So that means I'm starting up here somewhere at 25. Okay, so we'll just pretend that's 25. And then I know my graph is either increasing or decreasing. And who can tell me which one it is? It's increasing, right, because it's positive. Now, am I trying to be accurate here? No. I'm not being accurate right now. I'm just drawing lines that I know that I'm supposed to draw. I know it's increasing and I know it starts at 25. All right? But if I know that it's $393, I know that that's going to be $393. That's a sales. Right? So $393 in sales would have to go here. No, it wouldn't. Why? Because we already start with $25 in sales. So $393, is that my X or is it my Y or what do I know? And this is where people get lost. Okay, 393 stands for the X, so that means dollars has to be down here. So here we go. There's $393. And we said we needed all the answers greater than $393. So I go up here. Here's where my $393 are. And my answer for the graph is everything up here. It's like a generic circle. I'm circling all of the answers that are greater than 393. Okay, this will take some getting used to. I'm not worried about if you can do this. I am worried that you know that x is on the independent and y is on the dependent. Okay, so it's important that you understand that. Okay, x is on the independent, y is on the dependent. Okay, and then when you get answers, you're able to tell me, oh, I'm looking for all of the answers greater than. So that means obviously I'm going to the right. Just like I did on a number line, I go to the right. Okay. We'll get into more of the circling when we get into 2-4. Okay? So don't worry about if you're confused on the circling yet. Just understand how you're supposed to solve the problem and the next rule. Our next rule is involving reversing the sign. In other words, with inequality and equations, the work is done the exact same way except for one simple rule, which is if the number in front of my variable is negative, I have to remember to flip the inequality. So here's a problem, and I'm going to write it with a positive. So here are my two problems. The only thing that's different is in this problem the negative, and in this problem the negative is not in front of the x. Okay? So I do the math the same. This one has the rule, this one doesn't. So I pretend like this is equal, and I would minus 40, and I would also minus 40 from both sides. And you would have negative 20x is greater than, and in this case it would be 260, and over here it would be 260. The math hasn't changed. This is where the math changes. Why? Because in this problem I divide everything by a negative 20. And in this problem I'm dividing everything by a positive 20. Why? Because I divide by the same thing that was there. And our rule states that any time you divide by a negative, you have to flip the inequality. This one, we don't flip the inequality. Why? Because the x was negative in this problem, and it's not negative in this one. This is the big concept in this section, is understanding when you flip the inequality. Only when you multiply or divide by a negative number. Or when else could this happen? Well, the same thing happens when it's this. Here I have a problem where negative x is less than or equal to 15. I cannot have a negative variable. We've talked about this before. You always have to make the variable positive. But if you change this sign, then you have to change this sign. Well, with inequalities, you don't just change this sign, you change all the signs. So now the x becomes positive, the inequality flips, and then the other side becomes negative. Now, that is the same as if I were to have multiplied this whole side by negative 1. I multiply this by negative 1, two negatives make a, correct, positive. I multiply this side by negative 1, positive and negative make a negative. And because I multiplied or divide by a negative number, I flip the inequality. Either way works. I like simplicity. If I'm going to change this sign, I have to change all the signs. I can't just change one. All right, and that is 2-3. Next one is 2-4, and that's tomorrow. Have a good night, guys. We'll see you.